Well, thank you again for inviting me. I'm really pleased to be with you all tonight, and hopefully I can talk to you guys more on the air one day. I normally try to check in on the vintage sideband nets on 20 meters on Sunday. So you'll normally hear me with a 100V or 200V or some other, maybe even my S line. Occasionally, I'll even crank up my poor KWS1 and get it going. But anyway, I had met Wes, started an association with him back when I was in high school, actually, and I was fortunate enough to converse with him by letter and by telephone, and eventually got a chance to meet him. And once I did, we were just fast friends. And he had a very fascinating life, and one that I think you'll enjoy as we go through this presentation tonight. Now, lots of people don't even know who W9DYV was. But as far as promoting single sideband back in the very, very early days, in the late 1940s, early first couple of years of 1950, he was one of the principal fellows that was involved with developing single sideband for the amateurs in a way that the amateur radio operators could actually use it. And because I got involved with his early equipment when I was in high school, it was more of an education for me to learn something new and different, because as you'll find out, the principles he used, at least today, are kind of different. So back in the early days, now we're talking about in the aftermath of World War II, when hams were allowed to get back on the air, which happened a couple of years after the war. As you know, the federal government acquired or temporarily suspended amateur radio and utilized our frequencies in the war effort. That's why you have a lot of surplus crystals rolling around for 3885 and other frequencies that the AM crowd is utilizing today. Quite a few of those crystals are made and utilized in equipment in the war effort. But it's operating AM back then on the crowded bands of 75 meters and 20 meters was just tough. It was just nothing but a sea of heterodynes, whistles, QRM, and really only the strong stations got through. You had to have a big signal. QRP was non-existent back in those days. But there was hope. There were a number of hams that saw, opportunity in single sideband techniques. Most don't really aren't aware, but single sideband was used, in fact, during World War II. It was utilized by AT&T for secure telephone linkages between the United States and Europe on a limited basis, but it was being used and it was being perfected. And this information was available in the military, of course, but not very much of it leaked out into the public sector. But in those years, hams were off the air anyway. So they were principally involved in the war effort. But this thing called single sideband was just a way of providing highly efficient voice communications without the heterodynes. You don't necessarily need to transmit a carrier if you can re-eject the carrier signal in your receiver to demodulate the voice information. And that was the heart of the whole technique. Now, in 1948, the world, the amateur radio world at least, exploded with people that were experimenting with single sideband. And QST, the ARRL, published a number of articles in QST about the advantages of single sideband, how to utilize it, how to receive it. They even had a column that started in June of 1948, which was called On the Air with Single Sideband, being highly promoted by the ARRL as a means of resolving the QRM problems and also to utilize the limited spectrum that hams had for voice communications back then. Remember, most of the amateur work was done on CW because the transmitters were simple to make. Single sideband was more complicated. And because of that, its adaptation to amateur radio was slow. But there were effectively two groups that were involved in heavily researching the use of single sideband. One group was on the West Coast, principally researchers and students at Stanford University. The other group was in New York, working hams that were working for the General Electric Company. One of those fellows was Don Norgard, W9DYV. And what Don did was he developed some equipment that was published in GE Ham News on how to not only receive single sideband simply, but also to construct a very simple single sideband transmitter, which we'll talk about in a bit. But it was that which really got things going. Most of the single sideband experiments were done on a very, very high end of 75 meters, 39, 99.5 kilohertz lower sideband. Lower sideband, why? Because that way the single sideband emission was in the band. And of course, you had to have really decent sideband suppression, so you didn't get a visit from the FCC, of course, for being out of band. Now, Norgard's first transmitter, the one that he published in GE Ham News, was called the Single Sideband Junior, and it was just a little exciter. It generated a 5-watt single sideband signal. It only used a few tubes, but it only operated on one frequency. To get this to work on, for example, 75 meters, you had to adjust these slugs on the front of the exciter for not only the power amplifier stage, but also to ensure that you had the correct 90 degrees phase shift for the RF portion, which we'll talk about soon. Now, most are familiar with the filter approach to single sideband, how you get rid of one of the sidebands, either upper or lower sideband, and how you get rid of the carrier. Well, the carrier is eliminated by this stage called the balance modulator. You have a local oscillator and audio that both input the balance modulator. The result is a double sideband signal, so you have an upper and a lower sideband. But if the balance modulator is correctly adjusted, the carrier is suppressed, and it can be reduced in the order of anywhere from 40 to 50 decibels. Then that signal is passed through an appropriate filter, which eliminates either the upper or lower sideband. In this case, the filter is positioned to allow the upper sideband to pass through. And then it is amplified not by a Class C amplifier, which is typical for a CW signal, but one that is linear, and that it introduces negligible distortion because the intelligence is contained in this information in either the upper sideband or the lower sideband. So the amplifier has to be very clean and to eliminate intermodulation distortion. Now, back in the day, back in the early 40s, hams were homebrewing these filters. They were using surplus crystals that were available through World War II. Principally, they were used in tank radios, actual radios used in tanks and other vehicles in the war effort. But they found out that that these crystals principally were in the 400 kilohertz range. And if they netted enough of these crystals in a certain way, you could develop a filter that had a flat frequency response, but then very steep sides, which would allow you to eliminate the unwanted sideband. Now, there's another approach to doing this. the filter one we consider to be brute force because it rips the other sideband off. This one is a little more elegant. It uses trigonometric principles to reinforce one set of sidebands and eliminate another in a combining scheme. That is, first, the modulating signal, the audio, goes through a phase shift network. So one signal is 0 degrees phase shift. The other one is 90 degrees shifted. There's a carrier signal that's also phase shifted and inputs one of the balanced modulators. The other one is fed unshifted, so to speak. And in this, what you get then is two double sideband signals, upper sideband and lower sideband. They're on the same frequency because the carrier is the same, but they're shifted in phase. And the idea is in the summing amplifier, the summing junction prior to the linear amplifier, one set of sidebands gets reinforced, for example, the upper sideband, whereas the other sideband is 180 degrees out of phase with each other and cancels out. So that's how you can develop a single sideband without using a filter. So let's dial back again to the early 50s. Really, it was 1951 when sideband became more of a reality for amateurs. I mean, a lot of people were experimenting with it in the late 40s and early, even in 1950, but it was a tough thing to do. Even with Don's little single sideband junior, like I said, every time you wanted to move frequency, you may have to retune things. So it was not a, let's put it this way, it wasn't designed for the appliance operator. So someone had to make this thing right for single sideband and for amateurs, and it turned out to be this guy, Wes Schum, W9DYV. And this is a picture of him during the war years, where he worked for a company called Covert Dual Signal Corporation. Now you look at him and you say, man, he looks really young. And in fact, he was in his very early 20s working at Covert Dual. Reason for that is, people that grew up in the Depression, young people, they didn't have a lot of time to grow up. I mean, you're expected to carry your weight and do things early. It was known as coddling that kids have today. You were expected to do something and do it fast. And Wes was in that generation. And luckily, we had that generation because that's how we won World War II. Now, what Wes did with his company, which was called Central Electronics, and we'll get into that shortly, but generally, what he did was he took the single sideband principle that was in the Norgard exciter, and he made it more flexible. And the reason, or the way he did that, was he picked a 9 megahertz local oscillator. That was the frequency he decided to set to generate the single sideband signal at one frequency, 9 megahertz, and then heterodyne it up to different parts of the radio spectrum. So if you had, for example, a 5 megahertz signal from a VFO, and you mixed it with the output of his sideband exciter that we see here, this is the RF source, which is a carrier. It shifted 90 degrees in phase, as it says over here. Audio signal is likewise has a 90-degree phase shift. Feeds two balanced modulators, and a trick where one of the sidebands gets eliminated happens in this little link here before it goes to the next stage, which would be a mixer. So the signal from the VFO would input the mixer, and lo and behold, with a 5 megahertz signal and a 9 megahertz single sideband generated source, 5 plus 9 gives you 14. So, gee, you're in the 20 meter band, right? Or 5 megahertz minus 9 puts you in the 80 meter band. So with one 5 megahertz variable oscillator, you could operate two bands with this design. Wes, in fact, packaged a VFO that'll operate on all the bands, 160 through 10 meters. So it made this whole idea very flexible. And it was a technique that was used in receivers, except that Central Electronics was the first one that heterodyne principle to a transmitter. Now, this is Wes in his company by the time it was acquired by Zenith Radio. And what we see here is the groundbreaking 100V transmitter that his engineers developed. So, you know, he wanted to make single sideband not a novelty, but a true viable system. And the package design or the prototype for his first rig, the 10A, is this unit here. Now, as you look at the final product, the 10A, which was introduced in 1952, you see there's a pretty strong resemblance between the prototype and what was the final product. Now, the way this worked is that to change bands, you had to open this little door and change the mixer and final amplifier coils. They were plug-in coils. So you plugged it in, operated on a different band. If you changed bands, you had to change the coils. But it was flexible enough to operate on anything from 160 to 10 meters. Now, it had a number of firsts. Well, first off, it was a multi-mode exciter. It did amplitude modulation, phase modulation, single sideband, and CW. It generated sideband at 9 megahertz. It had Vox. I think it was the first transmitter commercially made that had Vox built in. It had what he called QT, like on the QT. And what that is today is what we call anti-Vox. It prevents the audio from your receiver from being picked up by the microphone and keying the transmitter up and keep cycling it. So he had anti-Vox as well as Vox in this little single sideband unit. He also developed a companion demodulator. I mean, you have to have a way of receiving single sideband, not just transmitting it. The AM receivers of the day didn't have the capability, it's not very well, of detecting single sideband, and that caused a whole plethora of problems because people just didn't like the way sideband sounded. They called it monkey chatter, buckshot, every kind of name you can, and they were very nasty about it. You know, it was tough being a sideband back then in the early days, which is one of the reasons why they like to hang on the high end of these bands in order that they didn't cause as much interference to the AMers that were operating traditional amplitude modulation. It was available wired or as a kit, and it just took off. I mean, he sold bunches of these sets. Again, this is the inside of the prototype. And if you have a 10A and take a peek at it, you'll see it looks very similar to this. Now, like most electronic startups, they start in the garage. And true to form, this is where Central Electronics started. It was on 2125 Giddings Street in Chicago. It was Wes's family home. Now, keep in mind, again, this was a young man in his early 20s in World War II, and he was working for the war effort. He wasn't drafted because the work he was doing at some of these companies that he worked for, principally COVID dual signal, was important to the war effort. He developed Army-based intercoms that used radio links rather than wires. They developed a specialized amplifier, tuned amplifier, which was used for torpedo countermeasures, which if you get my book, you'll read some pretty interesting stories about that. They also developed with the help of, actually it was developed by MIT Radiation Lab, but COVID Dual actually manufactured the first run of these microwave frequency meters, and they reconditioned radiosondes, which is a device that is hoisted up in the upper atmosphere by a weather balloon, and eventually the balloon breaks, this package comes flying, coasting down to Earth with a parachute. But on the way down, it measures things like atmospheric temperature, water density, water vapor density, a whole number of things, barometric pressure. All that stuff was recorded, and these devices were later picked up and reconditioned. And that's what Covert Dual did. They reconditioned them. And they also built a runway location transmitter system that was used. It was supposed to last for only 5 years. It turned out it lasted almost 30. It was used for a number of years at airports throughout the United States. Now, important thing about this setup here was Central Electronics first started in the basement, but then as the orders for these 10As kept coming in, he needed more space. So he and his wife moved the operation to the back garage. Now, the back garage had a service alley. So all the other houses in this neighborhood had garages that would look onto the service alley. And one by one, because the production kept growing, Wes would lease a garage. And pretty soon, he had 6 different garages leased up and down the service alley. And he used these students from the DeVry Institute that were starting to be electronic technicians. And so during the day, and really also at night, you would see guys running up and down the service alley with wheelbarrows hauling transformers and chassis and all sorts of bits and pieces to assemble the 10As, which are in the being put together in the main garage behind his house. Now, by then, when we're talking now in the 1953 timeframe, the 10A was really selling like crazy. In fact, Art Collins bought one. There's a story about that since I noticed the number of Collins collectors out there, Art was utilizing a KW1, which you would expect. He built this gigantic transmitter that was the pinnacle of AM as far as hams were concerned. I mean, it was extremely expensive. Only about 150 of them were made. But he was on the air on 20 meters, trying to work in DX. But he would hear these guys running these little 10A exciters and maybe an 811 amplifier, final amplifier, and beating him out in pileups. And he was getting a bit annoyed by that. So one day, Wes is in his office working on getting a load of equipment out, and the phone rings. His wife answers and said, "Wes, this is a fellow from Cedar Rapids, Iowa. He wants to talk to you." And it turned out it was Art Collins. And Collins said, "Hi, Art. I'm Wes. I'm Art Collins." I said, "Oh, yeah, Art, I know who you are. I've heard of you. I've heard you on the air a number of times." He said, "Well, would it be possible for me to get one of these 10A exciters? Because I hear them on the air all the time, and they're everywhere, and they sound good, and they work great. They seem to work great. I was wondering if you would sell us a few of them so we can get them on the air and experiment a little bit." And he said, "Oh, sure, Art, we'd be happy to do that. The only problem is we're all tapped out on already assembled 10As, but we have a run of kits coming out. If you have anybody up there that could assemble one." And he just kind of paused on the phone. And Art Collins coolly said, "Well, I think we can handle it. We can manage. Send them up." So he did. They sent the 4 of them up there. And it was weeks that went by. And Wes and his friends didn't hear the 10A on the air at Art's QTH. And they were kind of curious about that, why wasn't it on? And one day he gets another call. It's from Art. He said, "Look, I know these things work because I hear them on the air, but our guys can't get them to operate. I mean, it doesn't work. And can you call the office and talk to the folks that were putting these together and see what the problem is?" I said, "Oh, sure." So Wes calls him up. They talk for a few minutes, and it turns out what they were doing was, you see on the front of these exciters, there's a little crystal socket, just like every rig has a crystal socket back in those days. And you plug a crystal in and you go on the air. Well, you would if you had a multiplier type set that used an on frequency crystal. But if you plug one of those into a 10A, remember it works on a heterodiming scheme. So if you have an on frequency crystal, plug it in, you're not getting single sideband energy out where you think you're supposed to. And that was the problem. The guys didn't read the instructions. They wired them from the schematic, and that's why it didn't work. So they got that problem solved. And then he started hearing some of the guys in Cedar Rapids on sideband. Says, oh, this is great. So then fast forward another couple of months, he gets another call from Art Collins. And Art says, Wes, can we get 4 more of those units? But this time, no kids. So he wanted them pre-wired. Thought that Wes always thought that was just hilarious. But they were really good friends. Art Collins and Wes got along famously. And back then, in that era, manufacturers weren't as cutthroat as they are today. I mean, they actually cooperated with each other, shared ideas, because everybody was trying to make the hobby better. And it was just a different mindset back in the very, very early stages of single sideband's development. But back to these, the 10B was an improvement over the 10A. It had some features on it that made it simpler to operate. But Wes was astute enough to know that guys are getting tired of opening the lid and changing these coils all the time. So he came up with the improved version, which is the Model 20A, which was band switched. So it had a switch. You could switch from any band. It had a tuning indicator in it, so you can null the carrier and also adjust the final for maximum output. It just had lots of really neat features. They also increased the power from 10 watts PEP to 20. So it could fully drive any kind of amplifier that any one of the hams might want to homebrew at that point in time. Now this came out in 1954, both of these units about at the same time. But what Central Electronics, I guess, is most known for is its no tune concept. Now today, every radio you buy is no tuning. The only thing you tune is the VFO, right? You don't have to adjust the final amplifier, mixer stages, none of that stuff. It's all broadbanded way to go. You just turn the band, find the band you want, turn the VFO and start talking. Well, that wasn't the case back in the 50s. In fact, it wasn't the case in the early 70s. You had to, in many rigs, adjust the driver and final amplifier stages each time you change bands. So in 1953, Wes got a visit from this fella from down in Atlanta area. His name was Joe Batchelor. And he said, I've seen all this sideband stuff you have. Would you be interested in some in an amplifier that you didn't need to adjust a plate of load control? It just operated broadbanded, just turned it on and started talking. And Wes's eyes just lit up. He said, oh, of course. He said, does it have any motors or anything in it? He said, no, it's all done by the electronic design of these coupling transformers that I invented. Said, well, that was it. A marriage was built around the broadband coupler. So in 1954, late 54, they started developing this amplifier that Joe Batchelor had conjured up. And it really had some unique features. Now, keep in mind, this is 1954. It was 600 watts PEP, and it required no tuning. There was, the only controls you had on a 600L was the band switch and a meter switch and some switches to turn the thing on and off. And that was it. There was no plate control. There was no loading, none of that stuff. It was band switch neutralized. So as you switch bands, it automatically neutralized the final, optimized the neutralization for the single 813 final it used. The meter was indicated single SWR, watts input, and antenna current. You know, back then, amateurs were required to know what their input power was for their transmitters, which meant you had to know what the plate voltage was, you had to monitor the plate current, you multiply current times voltage, and you knew what the input power was. Simple Ohm's law. But what this device did was the meter was simply scaled to read out what the input power was. So you didn't have to do that calculation. Interesting thing too, it had a electronically regulated, voltage regulated, or excuse me, current regulated screen supply, which actually, if you have any of the old handbooks from the 60s, 1964, for example, there's a schematic of that screen regulator circuit that was invented by one of Wes's engineers. His name was Tom Clements, W9OKA. And Tom's design for the screen supply was in the handbook for about 6 years. Neat thing about it was it operated off the high voltage supply of the amplifier and used a 812 as a pass tube to regulate down to the between 600 and 800 volts that the screen wanted to see. So then again, this is 1954, and you had a no-tune amplifier. Now, no-tune amplifiers are pretty common today. Solid state amplifiers, they're all no-tune. You don't have to tune anything except turn the band switch. In fact, in some of these new rigs, the amplifier follows a transceiver, so you don't have to do anything except turn it on. But this was a big deal back in 1954. This is to the left is a picture of this 600L. Again, band switch, meter switch, this specially calibrated meter. It had protection circuits built in to protect the system from excessive plate current. If somebody tried to overdrive the amplifier, it would automatically put itself in a standby mode. Same thing would happen if the SWR, the antenna, was damaged. It would shut down and protect itself. It also had a step start circuit in it, which was brand new. None of the equipment back in that day, amateur equipment, had step start circuit to protect the capacitors in the power supply. You have them, you know, it's a pretty common thing to have in today's amplifiers, but in 1954, it was a big deal. Later, they developed this, the broadband transmitter that accompanied the 600L, and it was called the 100V. Now, it was started in 1955. What's cool about it? Well, it was 100 watts output and continuous duty. It had a self-contained power supply. It did all of these modes: sideband, double sideband, AM, phase modulation, and gee, it even included frequency shift keying for the guys that wanted to operate radio teletype, which was a mode that was just starting to gain popularity in ham bands in the early 50s. It had an active audio filter and processor. And what sideband rig, many of them, you know, it's common today to have processing, but back then, no, it was a rarity. It had a built-in modulation scope, extremely stable VFO, which I'll show you in a minute. They really strive to have a clean transmitter, and to do that, they used the highest linearity tubes that they could find at that time, which turned out to be audio tubes, 6BQ5 for the driver and 6550s in the final amplifier. Now, 6550 is a tube that's used audiophiles today because of their extremely low intermodulation distortion. Now you could achieve right at 40 dB, minus 40 dB IM with this setup back in 1955, but without feedback, which is really remarkable. These tubes were excellent. And of course, it had to have the no tune concept. And that was the neat thing about it. There was no tuning controls on this set, just like the amplifier. So you just switched the band, spotted the VFO on your receiver and started talking. It was configured also for break-in CW, FSK for RTTY. Now, let's dial back again. You know, how big was single sideband back in the early 1950s? I mean, how many people were actually on the air with sideband, say in 1951? There were less than 300 in the whole United States. But, you know, you keep in mind, though, the number of hams that were actually licensed back then was very small. You know, amateur radio may have been, even by the mid 1950s, you're talking about maybe only 75,000 licensed hams then. I mean, ham radio was not a hobby, anything like what we have today. I mean, lots of people say that, you know, ham radio is dying. I don't think you can consider a hobby that's got over 800,000 licensed hams anything on its last gasp yet. 1956 was a big deal for sidebanders. They would have these dinners, and principally in Chicago, New York were the two areas that had most of these single sideband dinners. And as you can see, everybody really thought these were a high-class deal. When was the last time you went to a ham fest and everybody was in coat and tie? But that's what this was. Oh, yeah? Okay, Dennis. Yeah, so these were big events, and people were really excited about single sideband back in the 50s. So why is Wes Schum amateur radio's unsung hero? Well, I mean, lots of people can build stuff in their garages, but this guy took the medicine show out on the road, and he promoted how single sideband worked and why it was so much better than amplitude modulation. Well over the 110 hamfest and sideband conventions throughout the United States in the early 50s. And he demonstrated sideband to people and showed them how easy it was to utilize it and operate it and make it work. And so that's what really got sideband off the charts. It got people interested in building it. A lot of people think, you know, Art Collins and Collins Radio invented single sideband. That's not true. I mean, but what they did was they built excellent equipment. There's no question about that. And certainly Collins Radio was instrumental in bringing single sideband to the Strategic Air Command and making sideband the premier mode of communications in the military. But as far as amateurs were concerned, it was W9DYV that ran the show in terms of getting single sideband promoted in the very early days of the hobby, of that part of the hobby. Now this is Wes Schum here, a 600L, a 20A rack mount. And this is that fellow Joe Batchelor. Now, Joe is responsible for so many of the patents that are involved with Central Electronics. Joe is just a true genius. These two guys were incredible as a team. Well, you know, they were selling these 10As, 10Bs, 20As like they were going out of style. And while that was going on, it was financing the development of the 100V transmitter. But to develop something that revolutionary, you have to remember, there was no amateur transmitter that was available that was no tune, or one that encompassed all of those modes and provided the features that this one did. It was just groundbreaking. So they were going through money like crazy. And at the end, they found themselves in the boat of, we've got plenty of R&D in this thing. We've actually got a prototype, but we're too broke now to actually produce it. What are we going to do? So they started looking for a noble sire, somebody that would come in, take their idea and bring it to market. And that turned out to be Zenith Radio. Zenith Electronics, or back then it was Zenith Radio, purchased the assets of Central Electronics in 1958. And because of that, they were able to go into production in a big way in this groundbreaking transmitter. So those were really exciting years for Central Electronics with Zenith's input. They brought in lots of engineering resources. They had the buying power of Zenith Radio behind them. So they got components and pieces and materials for these transmitters at much better pricing than they could ever do independently. And eventually 1,500 of them were made, and in the improved 200V transmitter, an initial run of 500 units was made. And that was over a period of 1958 to 1961. And they were really selling well. People loved the thing because it was just so unusual. This is what the inside of a 200V looks like. This is the RF portion of it. The heterodyne crystals to get it on the right band pass filters for each individual band. All this stuff was broadbanded. Final amplifier over here, a pair of 6550s. The modulation scope. This is the VFO. The back area here is the power supply. And this portion, this is the single sideband generator, which operated at 8 megahertz, not 9 like the earlier rigs. And this is the speech processing equipment and the relay and all that other stuff. So this is what it looked like, all broadbanded, no tuning. And they were really doing some remarkable things. The military, Zenith's military electronics group was developing the 100R receiver that was designed to transceive with the 100V and the 200V. So that was on the books coming out. Joe Batchelor's team was developing the 2500L. Well, the 600 watt PEP input 600L amplifier was nice, but it was really designed for the smaller exciters. They wanted to have a much bigger amplifier for the 100V, 200V line. It was going to be called the 2500L. And they actually had breadboarded it. So it was close to being produced. Then they wanted to develop a lower cost system, which they called the 50V and the 50R for 50V. The V means VFO. R, of course, means that's the receiver part of it. But it was a lower cost, stripped down version of the 100V. So everything was going great. All that stuff was set to be developed in the early 1962 timeframe. But then a big shock because they were doing so well and they had so many new products in the pipeline to be introduced in 1962. The 2500L amplifier, which would have been no tune also, using the same broadband principle. The mid-tier radios, a mobile rig. They even had a novice rig, which I have the prototype for. And CB radio was just taking off. So they wanted to get involved in that business too, because that would have kept their production capabilities up. But right after Thanksgiving in 1961, Wes was called in for a meeting, which he thought was going to be a planning meeting for these new products. And it turned out that the decision was made to deactivate Central Electronics. The reason? In 1961, towards the end of 61, Zenith was closing in on selling about $250 or so million worth of color television. Now, in today's money, we're talking 10 times that, where the amateur radio business was only running maybe 3 to 4 million. So for them, it didn't make sense for them to continue building such a limited market product when they had color television that was just taken off like a rocket ship. So suddenly it was gone. Zenith, by the way, did this again a couple of decades later when they acquired Heathkit and sold off the computer division of Heathkit, and then strangled Heathkit until it finally collapsed as well. They're not good when it comes to ham radio in long term. So, Wes lost everything at that point in time. He had spent all those years developing and promoting single sideband, developing the most advanced transmitters of that period, getting them sold in production. He lost his patents because they were owned by Zenith. They couldn't get them back. Zenith was uninterested in selling them back to Wes because they felt like, well, maybe at some point in time, maybe we'll get back into the military electronics or radio business and could use those ideas for military products. So suddenly he was without a business, without a source of income. And he had a wife, 4 daughters, a mother-in-law, and 2 female dogs. I mean, he couldn't win at home. He was surrounded by women, and they all looking at him to keep the lights burning. So, in typical Wes Shum fashion, he just barreled ahead, and he reinvented himself. He developed a line of high voltage test equipment that was used by initially Western Electric. Western Electric, well, the FCC had decreed that people should have the ability to interconnect to the telephone system. Back then, Ma Bell, as they used to call it, was very protective of its wired telephone network and didn't allow anybody to interconnect to it unless it was utilizing their equipment. The FCC said, well, no, that's really unfair. You have to allow other people to utilize this telecommunications network of yours. But they developed some strict interface requirements where products that were to interface to the telephone system had to undergo a high voltage test to ensure that the external equipment would not damage the telephone network. And that's where Wes came in. They didn't have the equipment readily available to do that. And Wes quickly conjured up some test sets, demonstrated them to Western Electric in Chicago, and quickly got an order for 1,500 of them. And that's what re-engaged him in a new line of business. So he eventually built a complete line of high voltage test sets that were used by companies like Motorola, AT&T, Bell Labs, Teletype Corporation, you name it. I mean, he had just a variety of customers, and his stuff was very innovative. One product that they made for the ADC Corporation, ADC, if you're in the telecommunications industry at all, you know that they make jack fields. They're used in broadcasting, microwave systems, in telephone systems, and jack fields are used for testing circuits. So you have a 1 rack unit panel that has maybe as many 24 or sometimes 48 jacks in it. And these jacks are relatively expensive to make because they're all machine parts and they have to be hand assembled and put into a product. And ADC was finding that they were having a lot of failures. And the result was in the machining process of actually making the metal parts for the jack fields, they had little tiny bits of metal that would attach to the jacks, and they would fall in the wrong spots once things started to vibrate a little bit as you handled these jack fields. So when Wes went to their facility, which they had one outside of Chicago, he said there was a stack 20 feet tall, nothing but defective jack fields. And it was growing. So he said, well, I think I can resolve that. And what he did was he developed a test set that would test all 24 of the jacks at one time. And if there was a piece of metal that was in the wrong spot, it would blast with a high voltage pulse and would vaporize the metal and recover the jack field. And suddenly that big stack of jack fields started getting smaller and smaller, and their yield was getting better and better. And so he found himself a new line of product to build that eventually was used to recover printed circuit boards that sometimes had little whiskers that were artifacts that weren't completely etched between traces. Motorola used them, that equipment, to recover lots of the printed circuit boards they were making at their facility in Schaumburg, Illinois. So, that's what happens when one door is, another door will open if you have the mindset to find it. So I wrote this book about Wes Shum, amateur radio's unsung hero, because so many people don't recall or really appreciate how many important contributions ham radios made to the art and science of radio, professional radio communications. Guys working in their labs at home, their workshops, conjuring up new circuit ideas or new product ideas, or just something that captures their imagination, and boom, it turns into something that's really unique that our consumers need. And it becomes a product, and it becomes an industry, and it employs people. That's the fascination I still find of amateur radio. It is a hobby that has so many different facets and can interest you in so many different ways. And one person can really make a difference. And I thought that Wes's story might inspire some young person that was, thinking of an idea or what he'd like to do or she'd like to do in life, and give them the incentive and courage to go ahead and follow that dream, and don't listen to people that are going to tell you no, what you want to do isn't going to work. The hell with that. Find out for yourself. If you want it bad enough, you'll make it work. You'll find a way. So in closing, Wes and I would like to say goodbye to y'all. That's Marge on the left, Wes in the middle, and of course me on the right. He was my best friend, my mentor. He became a second father, and we just had a wonderful relationship over 45 years. So, any questions, folks?
Okay, open up for questions here. I don't even see your hands up yet. How are we doing in chat, Barry?
Nothing in the chat right now.
Well, here's something you might be interested in. People always wonder about the broadband coupler. What does it look like? Because, it's buried inside the transmitter. You really can't see it. In the 600Ls, you really couldn't see it because they encapsulated them in this blue resin material, so you couldn't tell what it was. Lots of people actually tried to take these apart and cut them with a diamond saw and see how the internal windings of the coupling device were oriented, but that would destroy how it works. So that really didn't get them any place. This is the type that actually is in the 100 and 200V transmitter. What's neat about these, they're wired, they're wound externally. They did that in a coil shop. And they had two little prongs. You just plug it in. It has ground, input, and this is the high impedance side. So this is the 50 ohm side. This is the high impedance side, which is the plates end of the final amplifier, and ground. So it's a 3-terminal network. That's all it is.
Can you unshare your screen?
Yeah. Oh, you're not seeing it. hang on, let me get rid of this. See how I get rid of it now. Oh, stop share. All right, here we go.
All righty. Oscar, did I see your hand up a while ago? Guess not. Anybody else got a question?
Sorry, I was trying to unmute myself. Give me a break, Dan. You're too fast today. Nick, what a marvelous presentation. Really amazing. I called this in the RATPAC meeting. Tell me your stories. This is something that it should be recorded, and it's history, the real stuff. I mean, with the real guys, and even the technology that you're showing in your things that you have to do to survive and put things to work is amazing. Simplifying those circuitry and the theory behind it is really amazing. So I'm really glad to be here and listen to this presentation live. And how can we move ham radio in this kind of ideas? That would be the next level of thinking. What new ideas can be brought into the field for the newcomers and the youth and developing, because as you said clearly, the engineering, scientists, and technologies develop in many people who works in ham radio, but then it goes commercially and it goes the other way. But definitely the idea comes in roots related with ham radio. So back to you, Nick. Excellent presentation.
Well, I'm excited about the youth of today. I've gone to several different ham fests, especially the one I really enjoy is this one up in St. Louis. It's called Winterfest. And they invite young people in from the high schools that are doing all this maker stuff, in robotics. And they're really coming up with some amazing things, which, probably would have application in amateur radio in so many different ways. I mean, in antennas, in tracking systems for satellite communications. I'm looking at the background of your antenna farm with that H array with all those 450 antennas pointing up in the heavens. I think there's this long.
I think your satellite moved.
Yes.
To introduce ham radio, the facets of it to young people. I'm still enthralled by the ability to be able to communicate with someone on the other side of the world with the transmitters whose power output isn't any more than a 60-watt light bulb, and do it without wires, and it's magic. And I think if what excited us, when we were kids, probably would still excite young people today because it's different. It's not the internet, if legacy hobbies, like some people call ham radio, which I don't believe it is at all. Why would anybody go out fishing today? Because you can go to a restaurant and buy a fish, but it's the thrill of doing it. It's the learning involved in new skills and new hobbies. And I just think that amateur radio has lots to offer to young people. We just have to do a better job communicating. And that's really why I wrote the book, because Wes was instrumental in me when I was a kid, a young man, and I looked at him like, well, gee, here's this guy, I was in high school, then I was a freshman, so that made me, 14. And when I learned about his transmitter and realized that maybe he was 29 or 30 when he started developing his ideas about central electronics. And I'm thinking, well, if he could do that, why couldn't I do that? and I'm wondering if he would be kind enough at some point in time to show me the way. And I reached out to him, and he did. And believe me, I learned more about radio electronics working with Wes Schum building his high voltage test set line, while we were reminiscing about ham radio, central electronics, and ideas on making a better transmitter than I ever did in my my years over at Tulane University becoming an electrical engineer. All it takes is a person like that to open the door and engage your mind. We just need more of them.
And yes, ham radio is one of the few fields that you can do experiments in the air. And this is something that we can attract the youth. And somehow we are not exploring that field. And this is exactly what you were doing on those times.
Mm-hmm. Yeah, people don't realize how valuable this radio spectrum is that we have. I mean, it's a gift. And, because you think about it, the billions of dollars that the AT&T, Verizon, T-Mobile, all these companies are spending for spectrum so they can build cellular radio networks. And here we are, we have this spectrum that does so many spectacular things, and we have them in all different ranges, from the low part of the HF band all the way up into microwave. So I mean, there's something for everyone to experiment with, and you have the ability to utilize this natural workshop, and it's the license is incredible. I had to laugh. A lot of people are complaining about the FCC requiring us to pay $35 to renew. Man, what can you buy for $35? It's like this, nothing.
Thank you, Nick.
Thank you very much, Nick. Okay, any more hands up? I don't see any. Barry?
We're good in chat.
Okay, this has been an excellent presentation. Really appreciate it, Nick. And unless there's more to offer, anybody got any comments? Silence.
Going once, going twice.
Yeah, I do.
Okay.
Yeah, Tom up here. Yes, very interesting on the tuning and having to, stabilize the frequencies and things like that. Dad was involved with that at WNBZ here in Saranac Lake, which was one of the first early radio stations in the North Country up here in New York, northern New York. And of course, he was served in World War II and then came back over. And he put himself through radio college in Chicago back in 1935. So he was in radio for quite a long time. In 1948, he took the job at WNBZ and used to have to sign it on and sign it off to make sure everything was operating right. Now, they didn't have like you were talking about, they didn't have the tuning. The automatic tuner didn't come along to quite about the 70s sometimes. I think they came in with the tuners, maybe the early 70s, or late 60s. So yeah, very interesting. And he always said that with 20-watt sideband, he could talk just about halfway around the world. So with that, back over to you. Thanks for doing it. Great program tonight.
Yes. I see Dennis has got his hand up there. Nick, did you want to comment to what Tom was saying?
Well, no, but as he was talking about, broadcasting, and it brought to my memory, and I've got it in the book, but I'll just talk to you all about it, especially because of the Russians right now over in Ukraine. Wes got a call one day, actually it was a telegram, from a fella in Germany working for the Voice of America. And they were broadcasting VOA transmissions to Russia. But the Russians didn't particularly like that, so they were jamming the Voice of America signal. And this fella called up, at least sent Wes a note, just wanting to get his ideas and maybe how they could do some sort of countermeasures on this jamming problem. So Wes asked him, I said, well, what type of transmitter y'all using? And he said, he talked about it having a low level exciter driving this final amplifier. And he asked, well, is that a linear amplifier? And he said, well, yeah, it is. I mean, we can adjust the bias level on it and make it linear. I said, oh, okay. So why don't you just do this? Why don't you zero beat the Russian carrier and use a 10A as the modulation source on double sideband, suppress carrier, and you transmit double sideband energy with the voice broadcast information and use their carrier. Let's go for a free ride. And he said, that's a pretty good idea, because this guy had a 10A. It was a ham. And so they did that, and it worked. So it went on like that for a couple of months. And then he gets another note from this fellow over in Germany, for Voice of America. And he said, well, the Russians are starting to wobble their carrier. So it's messing up the ability of these stations over there to demodulate our AM signal. So what, you have any idea what we could do? And Wes thought about it for a little bit, and he said, well, do y'all have a remote receive site, to monitor your transmitted signal? I said, yeah, it's actually maybe 15, 20 miles away, so we don't overload the receiver. I said, oh, well, why don't you make a FM discriminator for the receiver, derive a DC signal that tracks the movement of the carrier. And Wes had developed a little reactance tube modulator circuit that he sent the guy to put in a 10A, and he did. And so as the Russians' carrier moved, the 10A signal moved with it, and it kept tracking it. So you could still listen to the Voice of America broadcast, even though the Russians kept moving their carrier, which was trying to jam it, right? So this went on for about 6 months or so, and then Wes got another report that the Russians gave up. They surrendered. So they stopped trying to jam Voice of America. But anyway, a little 10A had a role in beating the Russians. I hope the Ukrainians can do the same.
Very, very good. Very good.
Okay, Dennis, you got your hand up?
Yeah, that's a great story, Nick. I love that. Having dealt with one of their relay transmitters, which we did a program here some months ago. That's a great story. I love it. But I wanted to say thank you so much for coming and sharing this.
I appreciate you inviting me.
I'm really glad that we were able to reach out to you and get you to come and join us. And we'll thank Elon Musk and Starlink for upgrading your internet connection so that we could do this tonight. So this has been great. And
well, thank you so much. I enjoyed being with you all. I noticed you got a CX7 behind you too. I've got one downstairs. Yep.
That's actually a CX11.
Oh, excuse
that's
me. Okay.
Close. CX11 and
Yep. It looks the same. Yeah.
they do look the same. Yes, KW1380 and S lines in front of me, and on the other side over behind me over there, more S lines, and of course, like I do have a 20A.
There you
and
go.
a 458 VFO. Actually, I have two of them, and I believe, if I'm not mistaken, I think one of them came from you. I think it was one that you had restored.
Oh,
And
okay.
I picked that one up on eBay years ago. So very, very nice piece of equipment, and hopefully get that on the air before too long here. Not a lot of space to put all this gear on the air, so I'm running like 3 radios. That's it. We're pretty crowded, but man, this has just been wonderful, and I'm really happy to see that our friends from the Vintage Single Sideband Roundtable here in the West Coast on 75 meters. Mike, Jay, and Bill have been here. And I don't know if there's anybody else on from that, but that's great. You know, to have the guys here. You know, the recordings will be up on on YouTube, so they can go and see those as well. So this has been wonderful.
Great.
Okay, we're very
So
well.
again, thanks a bunch. And 73, guys.